Hello everyone, welcome to the channel. Here's another GCSE exam style question on forces. Please pause the video and try the question. When you're ready to check the answers, press play and compare your answers with mine. In questions like this, it's always beneficial to mark all the details in a clear diagram. A trolley of mass 2 kilograms, okay, so let's write the mass here, 2 kg, is pushed along a flat track from rest. So that means the initial velocity is 0. It travels 8 meters, so this is the distance traveled or displacement rather, along a straight line, and reaches a speed of 5 meters per second. So the final speed here is 5 meters per second. There is a constant resistive force of 4 newtons acting against the motion. So the motion is to the right, the constant resistive force is to the left, and 4 newtons. The constant resistive force is 4 newtons. Now I've got all the information on the diagram. Part A. Calculate the amount of work done to accelerate the trolley. Initially, the kinetic energy was 0 here because it has no speed. Now here there is a certain amount of kinetic energy. Obviously, work done is the same as kinetic energy gained. Now, working out kinetic energy is so easy. Half v squared, and you need to very carefully substitute half times the mass is 2, final speed is 5 squared. Now I know the answer is 25 joules. This is the amount of work done to accelerate the trolley. Part B. Work out the net force acting on the trolley during its motion. Now here's the thing. If you think about this object, right, this trolley, there's a resistive force of 4 newtons, but you need to exert a force here, a bigger force than that, say F. The overall force here is F take away 4. But the question is, work out the net force acting on the trolley during its motion. So work done is force multiplied by distance. So I know the work done here is kinetic energy gained. That is 25 is equal to F times by 8. Now all you need to do is force is 25 divided by 8, which is 3.125. So 3.13, let's say, to 2 decimal places, 3.13 newtons. Part C. Determine the size of the force applied to push the trolley. Oh, what is this force here? Now we know this force F take away 4, which is the resistive force, gives you the overall resultant force, which is 3.13. So obviously the value of force here is 4 add 3.13, so 7.13 newtons.